Good morning. I'm Deanna Hansberger, past president of the Mathematical Association of America. It's my great honor this morning to introduce our speaker, Della Dumbaugh, professor of mathematics at the University of Richmond. Before I begin the introduction, as one of Professor Dumbaugh's intellectual interests is the forming of communities, and since my life has been richer after meeting her at a JMM, please take a moment and greet the people sitting next to you.
Yeah.
Thank you. Professor Dumbaugh earned her bachelor's degree at the University of Mississippi and her PhD under Karen Partial at the University of Virginia in the history of mathematics. Upon completion of her PhD, Dumbaugh began teaching at the University of Richmond. Throughout her teaching career, she has taught mathematics across the curriculum, but she has also gone beyond the mathematics curriculum to develop a number of inspirational courses embracing the true meaning of the liberal arts. One such example is the spring break study abroad trip she developed with a student titled Vienna Circles, the Biography of a City, which involved walking around Vienna, Austria with a group of students, exploring the geography and the rich intellectual and cultural history of that beautiful city. More recently, Professor Dumbaugh designed a class where the students produced projects regarding early 20th century American mathematics that became the website AmericanMathematics.org, which launched in 2019. According to a Focus article from last fall, the website is the first of its kind to explore the people who create, the institutions that support, and the cultures that influence mathematics. The site is an extension of Dumbaugh's own intellectual pursuits. She is the leading authority on algebra and algebraists in the early 20th century America. Her work on Emile Artin and Leonard Dixon celebrates the power of collaborations, gives us a glimpse into the role of communities in advancing mathematics, and inspires us to learn more. She has received the Distinguished Educator Award from the University of Richmond, the State Council of Higher Education of Virginia TIAA-CREF Virginia Outstanding Faculty Award, and this past year she won the John M. Smith Award for Distinguished University Teaching from the MAA's Maryland, D.C., Virginia section. When asked what a historian of mathematics does, she has answered, "We study mathematics, the people who create mathematics, the institutions that support mathematics, the false starts in particular areas of mathematics, the politics that influence the development of mathematics, and how the larger cultural context impinges on the development of mathematics. This discipline combines technical questions in mathematics with appropriate historical questions to yield a rich perspective on both mathematics and history." I have had the pleasure of hearing Professor Dumbaugh speak on a number of occasions, and I can tell you that in her hands, the history of mathematics is much more than that. She tells us the interconnected stories of the people, culture, events, ideas, and mathematics, and makes the whole subject come alive. Her talks are distinctive and inspirational, and often somewhat personal, showing the humanity at the core of it all. Please help me in welcoming Professor Dumbaugh.
Okay, so thank you to Deanna, and thank you to all of you for awakening early to come and think about prospering through mathematics. I thought about this very carefully, prospering, and I chose it because I wanted to imply that abundance propagates elsewhere. And I want to explore the lives of 4 members of our community, Solomon Loveschutz, Emile Artin, Gertrude Cox, and Rudy Horne, and look at how they overcame challenges and they were able to propagate their success elsewhere. So let's begin. Let's begin with Solomon Loveschutz, and in particular, let's begin in 1884 in the city of Moscow, where he was born to parents he described as Russian Jews. And soon after he was born, they moved to Paris, France. This is where he was educated and began to learn multiple languages. He was introduced to geometry when he was 13, and from that point on, he described himself as mathematics mad. But unfortunately, since he was not a French citizen, he didn't have a bright future in France as a pure mathematician. So instead, he decided to study mechanical engineering. When he finished in 1905, he had developed an interest in electrical engineering and electricity, and there was no field of study in France for this. So he came to the country that was home to George Westinghouse and Thomas Edison, and the adopted home of Nikola Tesla. And he took a job at the Westinghouse plant outside of Pittsburgh. He was in an 11-month apprenticeship program that rotated around the plant. And in his 9th month, he was in the transformer section. And he was involved in an accident where he lost his hands and his forearms. Okay, so we're in this climate-controlled room just hearing about his life. But I want you to think about that. You're 23 years old, you've left your homeland, you're talented, you've gone to explore electricity and electrical engineering, and you have now lost your hands and your forearms. And it's 1907. So he has a long convalescence, he has rudimentary prosthesis, but it's 100 years before Dr. Bessel van der Kolk will write his groundbreaking work on trauma. The body keeps the score. And here, van der Kolk will tell us that trauma stays with us throughout our lives and reshapes our bodies and our minds. And one of the critical forms of healing is a loving relationship. But Lefschetz didn't know this then, but he would figure it out. So he reassessed, he went back to Westinghouse, they assigned him to a routine department. He felt unfulfilled and unsatisfied, so he decided to return to his first love, which was mathematics. So he went to Clark University in Worcester, Mass, and earned a PhD in a single year under the direction of William Story. He wrote a PhD on where he determined the maximum number of cusps on a plane curve of specific degree. And he learned to love a strong mathematics library. This point cannot be overstated. But the Clark Library had a special patron, Miss Alice Berg Hayes. And Lefschetz and Hayes would be married. When he took his position at Nebraska, after he graduated, she went along with him. She was a critical part of him adjusting to life without his hands and forearms and regaining his confidence. In the West, in the mathematical calm of the West, as Lefschetz would describe it, it was his lot in life to plant the harpoon of algebraic topology into the whale of algebraic geometry. And what he meant by this was he looked at the critical questions in algebraic geometry through the lens of what was then called analysis situs. We now call it topology, thanks to Lefschetz, actually. And by doing this, he accomplished two things. First of all, he revitalized algebraic geometry by showing that this new field could be applied to it. And second of all, he breathed life into what would become topology by showing it could be applied to other branches of mathematics. Well, he published this in a memoir, first in French. He won a prize from the National Academy of Sciences in Paris. Then this was translated into an article in the Transactions of the AMS, and he won the Bochet Prize. Well, this called him to the attention of the broader community, and in particular, Dean Henry Burchard Fine at Princeton University invited Lefschetz for a visiting position in 1924 and 1925. This position turned out to be the rest of Lefschetz's career. He remained there, succeeding Veblen as the Fine chair, becoming chair of the department at the end of his career. He immediately adopted Princeton's commitment to developing a research program, and for Lefschetz, his particular focus was on training the next generation. He served on the department representative to the graduate school committee, and he himself advised 29 students. I want to introduce you to 4 of those students. You might have heard of some of them. The Canadian Albert Tucker earned his PhD under Lefschetz's direction in topology. He would go on to anchor the Princeton department for 20 years as chair. He advised someone you might have heard of, a young man by the name of John Nash. John Tukey also earned his PhD in topology, but shifted his interest to statistics during the war. He founded the first department of statistics at Princeton. He also coined the term bit, and many consider him the father of data science today. Edward Beagle also earned a PhD in topology, but shifted his interest to education. I hope you're seeing a theme here. He led the school mathematics group in the 1960s, They were famously or infamously, depending on your perspective, responsible for the new math. And finally, John McCarthy also earned a PhD in topology, shifted his interest to computer science. He moved to Stanford, and you might know him as the founder of artificial intelligence. So I just wanted to show you Lefschatz's fingerprint card, just because it's so unusual. Lefschatz was also successful at an administrative level. He was president of the AMS in 1935 and 1936. He was chair of the Princeton Math Department, and perhaps his most important administrative role was he served as editor of the Annals of Mathematics for 3 decades. He saw 1,858 papers to publication, and his view of this work was, in his words, "It did not overwhelm me." When he took the position, his student Norman Steenrod described the Annals as a fledgling journal, and when he finished in 1958, it was considered America's best mathematics journal. He was also in let me just think about this for a second. Oh, I wanted to talk about his awards. Okay, so he was inducted into the National Academy of Science. He was awarded the Presidential Medal. He was given the highest awards offered by the countries of Mexico and Italy. And the French also attempted to nominate him for the Nobel Prize. They just ran into a little bit of trouble with this subject area. Late in his life, when he was in 1970, he died in 1972, he offered a mathematical reminiscence of his life. It was published in the Monthly. And there he said he had a budget of debts, which he would never be able to liquidate. And in particular, he named Alice for the strong encouragement she had been throughout his life, and the American university system, which allowed him to pursue his deep bent for mathematics. Important to our story, right after he stepped down as AMS president in 1936, in January of 1937, an algebraist in Germany came to his attention. And as he wrote to Father John O'Hara at Notre Dame, Lefschatz said, "He's married to a Jewish woman and they have two small kids, and you know the rest." And that German algebraist was Emil Artin. So Artin takes us to the vibrant city that I absolutely love, Vienna. He was born there in 1898 at the height of the Habsburg Empire, to an opera singer mother and an art dealer father. And the rich cultural heritage of Vienna remained with him his entire life. Richard Brouwer would later describe Emil Artin as much artist as mathematician. He went to the University of Vienna in the fall of 1916, but only remained for a semester because he was drafted into the Austrian army, where he served until 1919. Then he didn't go back to Vienna. He went to Leipzig, where he studied with Gustav Herglotz. He wrote a PhD in algebraic number theory. And the following year, 1921 and 22, he went to the mathematically vibrant city of Göttingen, where he studied with Richard Horan and David Hilbert. He also attended the chamber music hour at Richard Caron's house, which was held every week. Artin played all the keyboard instruments and was an accomplished flautist. Then the University of Hamburg had just opened. He joined the faculty there in 1926. He was made full professor. In 1927, at the age of 29, he proved Hilbert's 17th of the 23 problems he had posed at the Paris ICM in 1900. And in the same year, he established a general law of reciprocity that encompassed Gauss's law and all the other laws. So it was a banner year for Artin. 2 years later, he married his student, Natalie Jasny. Her father was Jewish, so she was considered Jewish. So when they had a couple of small children in the beginning of the 30s, they were also considered Jewish. So just consider this moment. You're in your early 30s. You've just established 2 key mathematical results. You have a new bride. You have some small children. And Hitler comes to power. And the laws start to close in on your family so that by 1937, you're eliminated from your position. So it's at this time that Lefschatz is stepping down as AMS president, but is aware of Artin's situation and aware that Notre Dame is building a research program in mathematics. They've just hired Karl Menger to come and lead the initiative. So Lefschatz writes to Father John O'Hara and says, "With 2 such stars in your firmament," meaning the leading algebraist, Emil Artin, and Karl Menger, Your department will only be surpassed by departments at the oldest institutions. So he convinces O'Hara, and now the Artines have a place to come for their first year in America. Of course, while they're there, Artine gives the lecture series at Notre Dame. They have a yearly lecture series on Galois theory. Some of you may know this book. His lectures were bundled into this book, and in the 50s, many aspiring mathematicians learned their Galois theory from this book. Of course, news of Artine's arrival spread quickly, and in particular to the chair at Indiana University at Bloomington, just 174 miles south of South Bend. So K.P. Williams went to his dean and said, hey, there's a leading algebraist, in fact, a leading mathematician right on our doorstep. He could come and strengthen the department. So the dean agrees to this, and now Artine has a permanent position the next year. The family moves to Bloomington, and many years later, Corinne would say, his daughter Corinne would say that it was then that they returned to their vibrant social life they left in Germany, and then that music returned to the home. So I want to show you a teaching schedule. I just want to ask you, does this look like something you might teach one semester? So you can communicate by putting your hands together. And I'll just say, this looks like something I might teach one semester, except for the graduate seminar, because we're an undergraduate institution. And then I want to tell you that this is Artine's teaching schedule for the spring of 1945. And I love this because he is one of us. The guy who proved Hilbert's 17th problem, the guy who established a general law of reciprocity, has a teaching semester that looks a lot like something we could be doing. So he feels a lot more real. He stayed at Indiana until 1946. Then he went to Princeton. It's a little unclear exactly how that came about. It seems like it was a confluence of 3 events. The first is that Wedderburn vacated the chair in algebra in 1945. Lefschetz became the chair of the department. And Hermann Weyl, who was Artine's good friend, was at the Institute for Advanced Study just down the road from Princeton. He remained there. The move to Princeton absolutely revitalized him. He began to publish again. He had 18 students there, including Serge Lang and John Tate. In the late 1950s, he visited Germany again on a sabbatical, and he returned there permanently in 1959. He died in 1962. While Artine was facing his own challenges at the very end of 1937, in 1937, Gertrude Cox was going to be facing similar challenges around this, was going to be facing her own challenges at a similar time in the middle part of America. She has such an interesting, unlikely story to mathematics. She was born on a farm outside of Dayton, Iowa, to a very strong Methodist family. And it was from her mother, Emma, she was very close with Emma, that she learned the joy of serving others. So she set out to commit her life to serving others. Her family moved to Perry, Iowa, so that she could finish high school. After she graduated, she spent a year teaching in a one-room schoolhouse. Then she attended the Iowa National Bible Training College, and then she acquired her real education when she served as a house mother to 16 small orphan boys. This experience set her on the career path of becoming a superintendent of the orphanage. But to take this position, she needed training and the credential of a bachelor degree, so she went to Iowa State. While at Iowa State, she studied psychology, sociology, and crafts, because these would all help her in her future career, but she majored in math because that was what was fun for her. She was the only woman in George Snedeker's calculus class, and he asked her to join his computing lab. This was 1925, and the computing lab meant human computers working on a comptometer. So these were used in statistics, primarily for computing correlation coefficients, and for a large statistics study with a lot of independent variables, it could take weeks to compute your data. But Cox loved this because it was a way to use mathematics to help people. In her second year, doing what we would now call undergraduate research, she published her first paper on an analysis of the Iowa State aptitude test, high school classes, and college courses taken by students. She stayed at Iowa State and finished her master's. She earned the very first master's degree at Iowa State, of course, under the direction of Snedeker. Then she went to the University of California, Berkeley, to study child psychology. While she was at Berkeley, Snedeker wrote to her and said, "I'm rapidly being drawn into statistical responsibilities for a large part of the college. Would you like to be a part of this? I think this would be a great opportunity." So Cox comes back to Iowa. She helps, I just hope you didn't see that. She comes back to Iowa. She helps him build the statistics program by doing two things. One, she oversees the computing lab. These are mostly women. David Allen Grier, in his book, When Computers Were Human in 2005, and a book you might have heard of by Margot Shetterly called Hidden Figures, both Grier and Shetterly identify that women were often chosen for these human computing positions, one, because of their attention to detail, but also because they could be paid less. That was only one part of Cox's job, though, in building this statistics program. Her bigger job was going out and about to work with researchers, to design experiments, set up analysis, and all of this taught her a great deal about experimental design. She and her later collaborator, Cochran, would ultimately put these ideas together in a book called Experimental Design, which was published in 1950 and is still in print today. There were three main ideas that they emphasized. One was that the statistician should be a part of the project right from the beginning to set the objectives and the analytical tools. Second, you randomize everything. That sounds completely normal to us in 2020, but this was highly unusual. And third, you use blocking. So this is an idea where you group your experimental units together by homogeneous attributes, like all the schools in a particular city or people with a disease at a particular stage. She was very successful, gained a reputation for herself, and in 1939 was appointed a research faculty member at Iowa State. But then a funny thing happened. The North Carolina State College School of Agriculture contacted Snedeker because they were going to add a department of statistics in 1940. And they asked Snedeker to send them a list of candidates to lead the department. So he compiled a list of men and showed it to Cox for her opinion. Now I want you to just think about this a minute. This is the professor who identified you as a young college student, young calculus student, asked you to work in his lab, oversaw the first master's at his institution where he's building a statistics program, brought you home from Berkeley to work side by side with him, put you in the field, had you oversee the human computing lab, but didn't recommend you for the position. But Cochran, Cox's collaborator, would later say she had learned in Iowa not to fail. So she said these 9 words to Snedeker: "Why didn't you put my name on the list?" So I want you to throw your shoulders back, and as my young exercise instructor says, pull in your core, and you say these 9 words. Why did you put my name on that list? Because you might need them. You might have to advocate for yourself or someone else one day. And I want you to remember Gertrude Cox. To Snedeker's credit, this is after the fact, he adds a PS that says, if you would consider a woman, I would recommend Gertrude Cox of my staff. Well, as Cochran will later say, there were some in North Carolina who believed at that time that women were too frail for this position, but the search committee knew their business, and they hired Cox. She built the statistics department at North Carolina State. You might know it today. She also, under the encouragement of her president, applied for a Rockefeller Foundation grant to start a statistics institute at North Carolina State. Then to start a statistics department at UNC Chapel Hill, she convinced Harold Holtelling to give up his position at Columbia and chair the department at UNC. And then she founded a statistics institute that served the Research Triangle area of Duke, North Carolina State, and UNC. When she left North Carolina State, she led the Statistics Institute. And when she retired from there, she took her ability to build statistics programs further afield to Thailand and to Egypt. She received many awards. One was North Carolina State named a building after her. Her favorite award, though, was that she was inducted into the National Academy of Science. She was president of the American Statistical Association. She started a journal and edited it. And when she died in 1978, she was still known for her hospitality. She loved welcoming children and international guests to her table. And to the end of her life, despite her immense success in the statistics community, she still loved giving talks at PTAs and women's clubs. When she died in 1978, Rudy Horne was just 10 years old. And he was living in the south side of Chicago at the intersection of Hermitage and 79th Street. Just 19 minutes away from a 4-year-old you might have heard of. When he was born in 1968, he was living just 19 minutes away from another American you might have heard of, Michelle Obama. In her memoir, Becoming, she talks about how her mother, Marion Robinson, used to say that she and her brother Craig weren't really special, that there were lots of talented kids in the south side of Chicago. They just needed a chance. Well, I'm gonna let you in on a little secret. Marion Robinson was right. There were other talented kids just 19 minutes away. Look at that cute little precious Rudy Horne. So he grew up in an entrepreneurial family. His parents owned a duplex. They lived on the first floor. Another family lived on the second floor. He was a very protective older brother to William and Frances. William described him as a brainiac, and he also described him as Rudy would listen to the aunts and uncles when they talked about doing well in school and going to college, but William said, it just went in one of my ears and out the other. So Horan did attend undergraduate. He went to the University of Oklahoma, and while he was there, he studied mathematics and physics. And to his great fortune, he participated in the inaugural 1989 SMART program at the University of Colorado. Okay, there we go. This program was designed to encourage underrepresented groups who were interested in STEM fields. This program would have a dramatic impact on Horne because he would return to Colorado for his graduate work, where he would earn a master's in physics, a master's in applied math, and in 2001, he would become the first African American to earn a PhD in applied math at the University of Colorado. In his dissertation under Mark Abelitz, he explored the long-distance transmission of signals via fiber optics. He also participated in the SMART program as a graduate advisor and in a new bridge program for engineering students developed on Yuri Treisman's model. And it was from these experiences that Horan learned that he really liked to encourage members of underrepresented groups to pursue mathematics. So after he graduated, he took a position in California. Then he returned to the East Coast, where he went to UNC Chapel Hill and joined the research lab of Chris Jones. There, he brought his mathematical expertise, and Jones also said he brought his enthusiastic spirit, which buoyed the team. But Jones has been very honest about the challenges that Horne faced, and he's written about his admiration for Horne as he faced rejection, doubt, and a lack of support. But he was always impressed by the way that Horne just got up and faced the next challenge. In 2010, Horne took a position at Morehouse College, and he loved this position. It gave him a chance to serve as a role model and as a mentor for young African-American men. His students remembered his enthusiasm, how it never seemed like he was working. But he was honest with them also about what the challenges that they would face. But he had a mantra: you can, you will, you should. In 2014, when Horne was at Morehouse, a 55-page document landed on film producer Donna Gigliotti's desk. And it was an unusual document because it was about African-American women mathematicians who had worked at NASA in the 1950s and 60s. Gigliotti is a producer who loves stories with women as protagonists. She brought us The Reader and Shakespeare in Love. And so she immediately bought the rights to the film and asked Theodore Melfi to work alongside her as a director. She was impressed with Melfi when he gave up his chance to be considered for the next Spider-Man movie to help with what became Hidden Figures. Melfi and Gigliotti were dedicated to showing a realistic view of African-American culture in the 50s and 60s. And to do that, they also meant they wanted to show an accurate culture of mathematics. But for this, they would need a mathematical consultant. So they approached Rudy Horne. They were filming on the Morehouse College campus. They approached Rudy Horne about serving as the mathematical consultant. And he said no. He felt it would interfere with his teaching and his dedication to his students. But his colleagues convinced him otherwise. And Horne did serve as the mathematical consultant for Hidden Figures. So what this meant for him is that on the 43 days of filming, he was there about a dozen times, and he was responsible for any mathematics that was written on paper or on the board. And at this moment, I see Rudy Horne's student, Zerati Woods, right now over there. I just spotted you. So he can testify. All right, so now I got to get my place back where I was. So he was responsible for any math on paper or on the blackboard. He was also responsible, you might remember Katherine Johnson teetering from the ladder suggesting Euler's method. Horne loved Euler's method, and as Horne's colleague and friend William Massey said, he did the math community a great service by making sure she pronounced it Euler's method instead of Euler's method. So when Taraji Henson was on the red carpet at the SAG Awards, I just want you to imagine this moment where she says, I don't want another young girl thinking that math or science is not for her. On the red carpet, I don't know how many times mathematics has been talked about, but I'd like to think that Rudy Horne's spirit is knit into that moment. This is a picture of Horne in 2017. So the film came out at Christmas time, 2016, and you all know the acclaim. It's brought in more than $236 million. This is Horne talking about his role in Hidden Figures at the CARMS meeting, the Conference for African American Researchers in the Mathematical Sciences, in July of 2017. And I just ask you a question. Is this man doing what he was meant to do on this planet? Oops. Oh. Okay, so at the end of the 2017 semester, in December of 2017, as his student Kevin Womack described it, Horne missed a couple of days of school, but then he came back and said everything was fine. But in actual fact, they never saw him again. He died on December 12th of a heart attack in the year after Hidden Figures came out. So I want you to think about Lefschetz. Whoops, I need to go back. Lefschetz, Artin, Cox, and Horne. So I've just put, this is the geography of their birth. And if you think about them just from the perspective of the geography of their birth, they offer a really diverse view of our community. If you think about their chronological dates, they span 136 years and bring us right up to this moment today. Their areas of interest are very diverse also. But if you think about them in terms of their spirit, they all prospered within the contours of mathematics. Not just prospered, they prospered through mathematics. And as a historian, one of the questions I like to always think about is how the past can inform the present. And I want us to think about what we can learn by their lives so that we can help the people around us to prosper. And the Harvard Business Review from March, April 2019 provides us with a good guide. And I'm just going to take their single idea and show you some ways that I've been able to work with it. So this is their issue on the feedback fallacy. You may be familiar with it. And their main point is that constructive criticism isn't nearly as helpful as identifying the strengths in someone around you. So I want to show you some ways that I've been able to do this in my classroom and with my colleagues. But first I want to remind you who's sitting in your classroom. So this is a little collection of stickers that came out this past semester. You might know the Boddington Stationery Company. It's a very sophisticated paper company. And these cute little stickers are designed for, let's say, 4th and 5th graders. And I want you to look how happy they are. There are about 50 in the little booklet. I just have about 10 up here, but I in particular included the 2 about math. So what do you notice about the 2 about math? Math, oops, with a grade of C+, and a calculator, extremely difficult math. But for art, I love art class, first prize art fair. So these students, you've heard of implicit bias, they start to adopt these viewpoints and then they end up in our classrooms. Now that's sort of bittersweet. So the bitter part of it is, this is the view of mathematics they have when they arrive in our classroom. The sweet part is, we don't have to do a whole lot to impress them. So start with your content. Right in the basic calculus class, the Meryl Streep, Tom Hanks of functions, the exponential and logarithmic function. You're going to be teaching these functions. I work with them almost every day. You can identify how these functions link with contemporary ideas. It gives you a perfect segue to talk about Carol Dweck's growth mindset, how you can view challenges instead of viewing them as obstacles, you can view them as stepping stones to success. You can talk about Jody Gerson, the CEO of Universal Music Publishing Group, and her growth leadership. She defines her success as a leader if the people around her are growing. And my favorite application, you can use the exponential and logarithmic function to talk to your students about their love life. And you can ask them, what do you want it to be like? Do you want it to be explosive, or would you rather it grow more slowly? We all agree on the growing part. And then, when you go to graduation, they'll introduce you to their parents and say something like, here's my math professor who taught me about love. I feel really satisfied about that. Okay, you can also suggest to them they might have a career they don't know about.
Everybody's talking about exponential growth and the stock market crashing in their portfolios.
So I don't know if Ed Sheeran was a math major, but that is the chorus from his song. 4 times he sings about exponential growth. So you can plant that seed too. We have the luxury of teaching about problems from different perspectives. This looks very routine to you, solving a definite integral by finding the antiderivative, evaluating at the upper and lower limits of integration, and also the geometric interpretation. We're so accustomed to this, the magic is out of it. But this is absolutely positively gorgeous mathematics, that you can think about this problem from 2 different ways. And your students are making an investment in their courage bank. Later, when you have a Palestinian and an Israeli trying to work out peace, they can think back, in my calculus class, I learned about how to think about problems from different perspectives. Do you remember that old saying about if you build it, they will come? Well, if you identify it, they will embrace it. Here's my student's solution to name one logical reasoning skill you learned in calculus. I really like learning about the definite integral because it teaches you to learn about problems from different perspectives. Finding the area under a curve. So our students come to us. Remember those little stickers? They're not feeling super great about math. They know how to find the area of a triangle, a rectangle, a circle, and we're going to ask them to find the area under a swoosh. Now just think about that. And we're not only going to ask them to do it, we're going to show them how to do it. And the way we do it is we compartmentalize it into smaller pieces. We take a big problem. We break it up into teeny tiny little pieces that we can solve. If you identify this, we have the privilege of teaching this. Our subject lends itself to this power. They'll say, take a big problem and break it into smaller pieces and it'll make your life easier. This doesn't just happen in calculus. I'm going to give you one hot off the press. I taught number theory last fall. A proof boils down to the definitions. A lot of things break down to the basics. When you have a complex problem, break it down to the basics. That sounds like a good life skill to me, and we teach it in mathematics. We use the 4th edition of Stewart to teach calculus at the University of Richmond because it's affordable, and the first chapter is dedicated to functions. This is a beautiful opportunity to help your students learn about how mathematics applies to their social life. At the end of that chapter, you start to think that functions are the cool kids, but then you have to ask, What about the unit circle? We're going to take all of trigonometry from that guy. So this is a good time to talk to students, to identify the strength of learning about functions and the unit circle, and realizing that not everybody who you think might be a cool kid is a cool kid. Okay, so that's what you can do day to day in the classroom. Once a semester, I go to 30,000 feet. I'm very strategic about when I do this. The Tuesday before Thanksgiving, right before students are going home, and we'll see their families. It's a little harder in the spring. It doesn't really work out with spring break. I give them a sheet with a single-space sheet of all the things that they've learned in calculus or number theory or whatever I'm teaching. And I say, okay, these are the skills you can leverage in the workplace. And there are some things you would expect, quantitative reasoning, logical reasoning. But I put a whole bunch of other things on there. You've achieved your goals despite your obstacles. And my latest addition, change management. Forbes identified the 10 top soft skills for the next 10 years, and change management is the top skill. Friends, calculus is the language of change. We only teach 2 key concepts, and they're both about change. So if you master calculus, you are an expert at change management. When I taught my Explorations in American Mathematics course, Deanna talked about this in the introduction, it had been a lifelong dream of mine to teach a class where my students produce projects that make up a website. If you click on one of those tiles, it'll tell you all about that moment in the history of American mathematics. I did the same thing. These were 3 exact lines from how you can leverage the skills you learned in this class. Envisioned, planned, and completed an original research project. You learned software skills, and you had to deal with ambiguity. I had a syllabus for that class. It changed by the minute, and those students rolled right along with me. But if you build it, they will come. I kid you not. A student asked me to write a recommendation for an internship. I asked her for her personal statement. This sentence was on her personal statement. In my Explorations in American Mathematics course, I envisioned, planned, and executed an individual research and media project from start to finish. So if you identify the strengths, the students will embrace it. At the end of Thanksgiving break, a different student wrote to me, after you gave us a list of workplace skills, I updated my resume. Okay, beyond content, you can just identify the skills you see in your students. The best advertisement for this is Tara Westover's Educated, which has been on the bestseller list, combined print and ebook, for 97 weeks. That's older than some of your children, I would bet. That is a long time, almost 2 years. And if you read the back cover, the book has been endorsed by Barack Obama, it's been endorsed by Bill Gates, and there are a bunch of little snippets that talk about how this book talks about what you take from home and what you leave behind and the love of a family, etc. But I'm gonna let you in on a little secret. There are 15 pages in the middle of this book that underscore the power of identifying skills for a college professor. And I'm not talking about meeting with a student for 2 hours every week. I'm not talking about that. Westover's life is dramatically changed by a college professor who says just this sentence: there's a summer program I think you would be a good fit for. I think you should apply. And then when she gets on the summer program, the same college professor is with her. She doesn't feel like she belongs. I won't go and spoil the story about why she doesn't feel like that. She doesn't feel like she belongs to the group. But then they go on a tour of a cathedral. They're in Cambridge, England. They're all on the roof of this cathedral. The professor and all the other students are clinging to the wall like this. But Tara Westover is bounding all around on the roof because of her childhood, for reasons I won't tell you about. But the professor inches his way out to her, and in that moment says to her, "You belong." So, you can identify content. You can identify what your class brings from 30,000 feet, but you can also identify the strengths of a single human being. I'm gonna show you my favorite example from my own class. This is from the fall of 2017. I was teaching linear algebra. It was time for the first test. The students were forming one of these group chats where they text each other about studying. And two of the students didn't give the student who was putting it together their information. So the student wrote to me and said, I'd hate for them to miss out. Can you send me their info? So I asked the student if I could print this email out and give it to the class. And I did that. And then I said to the students, you know, we have this big emphasis on inclusivity, and it kind of gets lost. We don't know what it means. But take note, this is what it means. You have a classmate who wants everybody included. That's what it means. Well, here was the fringe benefit of that. Every day in the banter before class, my students were assessing my colleagues, other students, on their ability to be inclusive or not. I have a little secret place in my brain of all those discussions. That student, when she turned in her final at the end of the semester, I was working at the desk, she brought it up, she put it in the pile, and she put her hand out like this. And I thought, I think this has happened like 3 times in my career. I shook her hand and she said, thank you so much for telling me that I know how to bring people together. I didn't know I had that skill. And I thought to myself, I'm really not so sure if I care if she remembers the definition of a vector space. I am. But I really care that she learned that she knows how to bring people together. And this is no secret.
He's gonna do it! You gotta see this! Oh, he's gonna do it! Come on, come on, come on! He's gonna do it! I got him. Nice. Come on. Yeah, let's go. All right. So how about another game?
Okay, so if you don't know where to start, you can always start by believing in your students. So there's a great example of this. Jojo Moyes, you might remember. She had a book called Me Before You that became a movie. You might recognize that's Daenerys Targaryen, who has another name. Her book, Me Before You, became a movie. She subsequently wrote a sequel, After You, and Still Me is the third, but maybe not final. She's left it open. She is an absolute master at taking up issues of social justice in her novels. In Still Me, though, Louisa Clark, who's the protagonist from the very beginning, has still not really found her footing. Louisa doesn't really love school. What she loves is fabric and buttons and zippers and hooks and eyes. That's what she loves. And in the last book, Still Me, she meets an older woman named Margot DeWitt, who worked in the fashion industry in the 30s and 40s and has a beautiful collection of clothes from Chanel and Givenchy. And she says to Louisa, I don't want to spoil it all, but she says, I'm going to give you my wardrobe, and I want to suggest to you that you form a clothes agency. It would be a good fit for you, and you can do it. And then you see, because Jojo Moyes is so brilliant, you see what Louisa Clark is thinking. She says, me? I've been a failure at everything I've ever done. Doesn't that sound like your math students? I can't do this. I don't know how to keep books. I don't know how to work with the public, but I'm going to learn how. And you can also look in the last half of the 20th century, George Mackey, who anchored the Harvard math department. The very end of his life, he was writing a commentary on his PhD advisor, Marshall Stone, but he couldn't help but remember a faculty member he'd had as an undergraduate at Rice named Walter Layton, who assured him he was good enough to apply to Harvard. So if you don't know where to start, start by telling your students you believe in them. And you can do this with your colleagues. This is my precious young colleague who unfortunately is off to Richmond. But in her first year, we were hiring, and it became really clear to us that she has this superpower skill of identifying the strengths of candidates. So we, as a department, we were able to encourage her to say, look, this is what you should do for your service. You're a natural. You want to build up your department? Start telling people what they're good at. There you are. You're that last little square, rectangle. So by the time you get to the top of that staircase out there, I want you to have identified one person. Write them on your mathematical heart. It can be your colleague, it can be your student. And when you get home, I want you to identify a strength that they have. And then I want you to follow up with an email to me. Thanks so much. So are there questions? Yes. Oh.
Thank you so much. We have time for a couple of questions. If you want to go to a microphone that's in one of the aisles.
Oh.
Yes.
So, can you hear me? So at the beginning of the talk, you were talking about Lefschetz. Is that how you say his name? After he became injured, how did he physically do mathematics? Did he have a scribe, or how was he active? And
So when I spoke about the rudimentary prosthesis, I actually don't know about the early years, but I can tell you about the years when he was at Princeton. He eventually had a wooden hand made, which he kept covered with leather gloves, and it was made in such a way that a piece of chalk fit right here, or a pencil. So I'm using my left hand. I actually don't know if he was left or right-handed, but anyway. So he could, every morning someone put the chalk or pencil in his hand for him. And he never talked about his injury ever. Princeton made a special lock on his door that he could actually get in with it, but he was so fascinated. Remember, he's an engineer at heart. He was so fascinated with the way it worked, he showed everybody how it worked. So he could hold a pencil though. Good question. That's my colleague, Joanna Wares.
All right, let's take any other questions up to Della afterwards and wrap this up. Thank you very much for a fantastic talk.